Juvenile salmon enter the ocean, and a large number of them die. And the issue then is what kills them.
As a fisherman, observation is the key to success, right?
Yeah.
And that's all you guys are doing, just a more specific type of observation with more.
The key in understanding what affects salmon abundance is to understand if you get 3% of the juveniles surviving, it can be a really good return. If you get 1% surviving, it can be a poor return. So a difference between 1 and 3% or 1 and 5% makes a huge difference in the number of fish coming back. In the mid-1980s was when the catches started to decline. In the mid-1970s, the average catch of Chinook salmon in the Strait of Georgia by commercial and by sports fishermen was about 800,000 fish. Today, the total catch is about 20,000. So we've gone from a huge catch to next to nothing. This project is designed to understand why that occurred so that we can rebuild the catches back to a level that improves the overall recreational fishery. The project is a 5-year project that Brian Riddle was able to secure about $10 million for. Importantly, it's a project that is also going on in Puget Sound. So it's an international effort by a group of scientists that range from oceanographers through to fisheries biologists who are trying to understand the factors that cause mortality of Chinook and coho in the early marine period.
We'll be doing a survey of different microbes that are potential pathogen causes. And then we're also looking for any changes within the actual cells of the fish or gene expression of the fish that might indicate the health and overall health of the fish.
Scientists around the Pacific have been studying salmon for over 100 years. And it's no exaggeration to say we really have very little information on what causes that mortality.
Well, we're using a small boat, and we're using Scotty downriggers, the same type of equipment that recreational fishermen use. And rather than a rod and reel, we're using 6 lines aside, clipped directly to the downriggers, and very, very small lures, very, very small hooks. And we put that gear down for 5 minutes at a time, and then retrieve it. These are our lines down there. So we have, at the moment, we've got 6 lines down on either side, down to 30 meters. So the small boat approach, there's an increasing move towards citizen science type projects. And this small boat approach makes the science accessible to community groups or First Nations or nonprofits who may not have access to the resources for the big ship work. Oh, I think we got a fish here. We do. That's a little guy. Nice. What we do with these guys is we do biological sampling. We will take scales, and those scales will be used for genetic stock identification, so we know what river system it came from. And then we're also going to take a small muscle biopsy from the fish. That little bit of muscle we're going to use to assess how fast that fish is growing. And then finally, we're going to inject a passive integrative transponder tag, a PIT tag. Just gets injected here. So this guy has been tagged and given the whole treatment. And there he goes. Yeah, that was a good day. Yeah, it's always a good day when you're fishing.
On this boat, we want to sample both the fish community and the water that the fish are living in. So to do that, we're catching the fish with a large trawl net that's about 40 meters wide by 15 meters deep, and we fish at a different level so we can see who lives where in the water column. This is a collaborative program between DFO, the Pacific Salmon Foundation, and the Pacific Salmon Commission. So we're doing a number of different studies while we're on the vessel. The work on juvenile Chinook salmon is a collaborative project with the Pacific Salmon Foundation. We've been conducting this survey for about 15 years now, since 1998. And from this survey, we can actually estimate the abundance of the juvenile salmon, and we can take a look at their size and their distribution. We want to know how big they are. We're measuring length and weight.
1, 2, 3, 2, 0.
So behind me, Carol is looking at the diets of these juvenile sockeye salmon, and she's identifying the volume that's in their stomach and the digestion rate and the major prey groups that are in there and the proportion of each prey group that's in the gut contents.
I see euphausids in there, and I see hyperids in there.
And that's being recorded by Lenora off to my left. Mary is taking some of those gut contents and freezing them in bags for an RNA-DNA ratio analysis that will be done later on in the laboratory. We're taking muscle tissue to take a look at fatty acid composition. We have somebody on board who's taking blood samples, and that's to sample for IGF. We're removing the otoliths from the fish. One of the structures we remove from the salmon is their otoliths, or their ear bones, and they're just a small. A number of the fish are being sampled for Christy Miller's lab at the biological station. And what the girls are doing in that lab is they're removing small parts of the tissue, so the brain, the head kidney, a piece of the liver, some of the gut tissue, some muscle tissue, and they're put into formalin to do some molecular work back at the biological station. When the catch comes on board, sometimes we'll catch other species like dogfish, pollock, lamprey, anchovies. It could be a number of different fish. If the fish are alive and they come on board, we measure them and release them immediately back into the ocean. To sample the actual water, we use 2 different pieces of equipment. The first is called a CTV, and we cast that to 250 meters. It's a piece piece of electronic equipment that measures temperature, salinity, dissolved oxygen, pH, conductivity, fluorescence as it's going down through the water column.
Okay, Sean, let's go down to 10 and back to the surface.
Roger, down to 10.
We can see that on a monitor and see how the temperature and the salinity changes with depth. In addition, we're sampling the plankton, specifically the zooplankton. So we use a very small mesh net to collect those, and we cast that down to 250 meters. And when it comes up, we preserve that in a preservative so we can take it back to the lab and identify all the small critters that may be similar to what's in the salmon diet.
Yeah.